So today we're going to do some calculations with our standing waves because we're going to be trying to figure out what the frequency of some of these things are. So I want you to get the standing wave note page out again, and we're going to add some frequency formulas to it. For the vibrating string, this is our formula. It's going to be the speed divided by double the length of the string, and that's because this right here is only half of a wave. A full wave is going to be twice as long as that. And then for the different harmonics, you're going to multiply it by the harmonic number. In this case, the harmonic number is 1 for the first harmonic. And remember, I told you the other day, you have to have this memorized. The fundamental frequency is what they call the first harmonic. So whenever you see fundamental frequencies, you have to know n equals 1 for your calculation. On the back side was the vibrating column of air. We had the closed pipe. So this is the formula for the closed pipe. And we have a large number. We have 8,600 divided by the length of the pipe times our harmonic number again. And this number is so big because we do our measurements in centimeters, but our speed is measured in meters per second. So we're multiplying by 100, and that's why this number is a little bit larger than normal. And for the bottom one, the open pipe, this is a formula. It'd be 17,300 divided by the length of the pipe, and that's going to be our fundamental frequency, and then we're going to multiply that by the harmonic number to tell us the frequency for any one of the harmonics. So I want to do some practice problems for our worksheet today for standing waves. Our first problem says, what frequency is heard from a 128 centimeter long closed pipe? So first we have to look at our formulas. We have formula for the open pipe and for a closed pipe. And then for each one of the pipes we have two formulas. Are we trying to find the frequency or are we trying to find the length? This one's asking for frequency and it's a closed pipe. So the closed pipe frequency formula is this one. So I'm going to start with that. And then I have two things to plug in. I have my length, 128 is on the bottom, so we're going to divide by that. But I also have to figure out what harmonic number it is. Remember on our notes we said that the frequency that you hear is the first harmonic, and that's the one that had the special name, the fundamental frequency. So we're going to be using 1 because our first harmonic is the one that you hear. So plug in the numbers and I have 8,600. We're dividing by 128 and then multiplying by 1. So our numbers today are going to be long numbers like this one because you're dividing on the calculator. So we're going to round it off somewhere. In physics, the rule is you count how many digits are in your measurement. I have 1, 2, 3, so we're going to round it off at 3 places. So 8's more than half is going to round the 1 up to a 2. And frequency has the unit label hertz. So this will be 67.2 hertz. And that means that pipe, the air in the pipe is going to vibrate back and forth 67.2 times every second. Second problem, what length of pipe would make the second harmonic with a frequency of 1260 hertz? So for our formula, this time we need the open pipe, so it's going to be the top formulas. And this time they're asking for the length, so we want the L formula. So we're going to be doing this one. So we have two things to plug in. Our frequency is going to be 1260, and our harmonic number, N, is going to be second harmonic. It's going to be 2. So I got 17,300. We're going to divide by 1260 and then multiply by 2. Again, we have a long number on the calculator. We're going to have to round it off. This one, let's just do 3 places. So we'll go 27.5. And our lengths are measured in centimeters using the metric system. Next example, what is the speed of a wave in a guitar string with a length of 55 centimeters and a fundamental frequency of 220 hertz? So this time we're using the string formulas, and the string formula has 3 different versions depending on what they want us to find. Are we finding the frequency or the length of the string or the speed of the wave? So this time they're asking for what is the speed. So we're going to use the speed formula as this one. And then we have three things to plug in. We need the frequency is 228, and the length was 55, and then our harmonic number, remember the fundamental frequency has a harmonic of 1. So I have 2 times 128 times 55 divided by 1 on the calculator. And that comes out to 14,080. And our speeds are going to be in centimeters per second today because we're measuring our lengths in centimeters. I have some similar problems to these to do on your assignment today. End of examples.